Measures of variation tells us something about the differences in the pieces of data we have. One of those ways we can measure variation is with range, which is simply the largest data value minus the smallest data value. Let's look at these two sets of data. The first one has a largest data value of 8 and a smallest of 2, so its range is 8 minus 2, or 6. The second set of data has a largest value of 13 and a smallest of 1, so its range is 13 minus 1, which is 12. If we have a larger range, then the data is more spread out from end to end. Two other measures of variation are variance and standard deviation. Variance and standard deviation tell us about the distance between the data values and the mean of that set of data. Let's use the same two sets of data that we had before and find the variance and standard deviation for them. We'll organize this process by using a table. In the first column, we'll put the 5 values that we have. The second column is the deviation, or the distance each of those values is from the mean of the data. So we need to find the mean by adding all the data values together and dividing by the number of data values. So the mean for this data set is 5. To find the deviation from the mean, we take each data value and subtract the mean from it. So for 2, the deviation from the mean is -3, which means that 2 is 3 below the mean. For 4, the deviation is -1. 4 is 1 below the mean of 5. For 5, the deviation from the mean is 0, meaning it is the mean. 6 is 1 above the mean, and 8 is 3 above the mean. Once you've got the deviations, go ahead and add them up. You'll always get a 0 if you've done everything right so far. The next thing we need to do is square each of the deviations. -3 squared is -3 times -3, which is 9. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 3 squared is 9. Now we're ready to find the variance. To find the variance, take that total of the squared deviations, the 20, and divide it by 1 less than the number of data values you have. So we'll take 20 and divide it by 5 minus 1. We have 5 data values. 1 less than 5 is 4. So 20 divided by 4 is 5, and that's our variance. To find standard deviation, take the square root of the variance. Unless the variance was a perfect square, you will get a decimal of some sort, so you'll have to have some sort of rounding rules. We'll just make a decision here to round to the nearest hundredth. So the standard deviation is about 2.24. Now let's go through the same process with our other data set. We'll put each of the values in our table. We need to know what the mean of the values is, so we add the values together and divide by the number of values. These values also add up to 25, and we have 5 of them, so the mean is 25 divided by 5, which is 5. To find the deviation from the mean, we take each value and subtract the mean from it. So the deviation for 1 is -4. It's 4 below the mean of 5. For 2, the deviation is -3. For 4, the deviation is -1. For 5, the deviation is 0. It is the mean. And for 13, the deviation is 8. What you should notice is that for any value that's below the mean, the deviation is negative. For any value that's above the mean, the deviation is positive. And for any value that is the mean, the deviation is 0. As a check, we can add all those deviations together. And if they add up to 0, we can be pretty sure that we've done everything right so far. Now let's square the deviations. So -4 squared is 16, -3 squared is 9, -1 squared is 1, 0 squared is 0, and 8 squared is 64. We'll need to total all those squared deviations in order to find the variance. The variance is the total of the squared deviations divided by 1 less than the number of numbers. There are 5 numbers, so we'll divide by 5 minus 1, or 4. 90 divided by 4 is 22.5. And to find the standard deviation, we just take the square root of the variance, which, if we round to the nearest hundredth like we did with the last problem, is 4.74. Now let's compare the two data sets. They did have the same mean, but the second data set had a much larger variance and a much larger standard deviation than the first data set. That does tell us something. It tells us that the second data set had values that were much more spread out from the mean than the first data set is. So if we have data that is more spread from the mean of that data set, the variance and standard deviation will be larger. And if we have data that's much closer to the mean for that data set, the variance and standard deviation will be smaller.